All right, this is going to be after the alternator is finally assembled, put it onto our test bench. We're going to be able to test this thing for a couple things Rob talked about today in class. When an alternator charging system is fully functioning, the two real important tests that we're going to do, we're going to look at regulated voltage and we're going to look at rated output of amps. Right? Now, to do a regulated voltage check, the most important fact you need to know is that the alternator must be producing less than 30% of its rated output. So, for instance, if I have a 100 amp alternator, it must be producing less than 30 amps for me to read regulated voltage. Any more than that, and it's going to start to lower the amount of voltage it's able to produce. It's like a battery. If I've got a 12.6 volt battery, it's going to be able to produce 12.6 volts until I start adding amperage to it, right? Let's say I do a cranking system test and I turn my key and I start cranking that starter. You saw what happened last week. Battery voltage drops off to 11, 10, somewhere down around there. Um, our alternator, being a power supply, is no different. As long as it's not producing or not required to put out amperage through any kind of a circuit, it's going to be able to put out full voltage. As soon as I ask it to send amperage through a bunch of circuits, that voltage is going to drop off. And we'll be able to see this on a couple of screens here. Right? So on this screen, I'm going to see what they call battery voltage, but that's going to be my alternator's output voltage. And that's going to be how many amps the alternator outputs. This is a fully assembled alternator another group has worked on, different class. But we're going to take a look at the numbers on here. So start the machine up. First thing it's going to do is it's going to bias check. Similar to what you did when you first took the alternator apart. That's the last thing your group did when they assembled the alternator, was they did a bias check between the B positive and case of the alternator. As long as it's good, this thing will do a couple of self checks, and then you'll hear it start to spin the alternator up right away. This is good because this tells me there's nothing output from that alternator. I'm going to stop it. And being a good instructor, I like to point out my faults. There's nothing hooked up to the back of the alternator. So, being a single wire alternator, you hook up battery positive and ground. Give that alternator some circuit to work from. Now let's try this again. All right, now we've got output from the alternator. What I'm looking at, I've got voltage out of my alternator and amperage out of my alternator. I need to test this thing at a specific RPM. Typically, we like to say it's around 5,000. So I can bump speed up, spin the alternator up a little bit faster, and we can see I've only got 15 amps output on this. So I should be looking at my rated voltage here. That's going to be real close to the voltage that we just checked on that board. So less than 30% of this alternator's rated output, I'm looking at full regulated voltage. All I've got to do to check maximum output for current is bump up my load here. So I can go from what I got right now, about 10% load, and go all the way up as close to 100% load as I can get. And then I can look at maximum output. I don't want to do that high. I never want to load this thing up more than battery voltage. So I should never make that drop below 12.6. But as long as I'm a little bit under that, just let me adjust this. About there, that's about as high as I'm going to get. I'm sitting at 13.09 volts output, so it's higher than battery voltage, which means my alternator is the only thing contributing the amperage. and it's at about 170 amps. This alternator probably only rated for 150 amps, so getting almost 170 amps out of it is a pretty good deal. It's also generating a lot of heat. You can't feel it through the video, but that alternator is getting hot because it's putting out so much amperage. One other thing I like to point out when we do these checks on here, sorry, didn't mean to bump your shoulder, but take a look on this screen right here. This is that ripple voltage. In class, when we looked at it, when I rectify the voltage, and I take those little bumps on the bottom, and I fold them over onto the top to get my actual rectified voltage, there's all of those bumps that went up and down. That's what we're looking at here, and you can see that they're in groups of 3. So that's my A phase, B phase, C phase that we can look at there. And we take the load away. Go back down to minimum load. My 3 phases aren't as obvious, but I can still see I've got a ripple voltage there. That's your final alternator checks that we can do on a bench. Now, on unit testing is no different. You're doing 2 different tests. Regulated voltage, which means I need no amperage draw. So you start your engine up. On the engine, you're going to want to go to about 1500 RPM. Because these are about 5 to 1 for alternator pulley to crank pulley size. So as long as my alternator is spinning up fairly fast, my engine's doing about 1500 RPM. With no load, I'll see my regulated voltage. And then I turn on everything I can. In a unit, you turn on all the lights, the heater motor, the heated seat, high beams, everything you can to try and get up to that rated output of amperage. If you can't do that, then you put a carbon pile on the batteries and you draw it down until your voltage is just above battery voltage, say about 12.8 to 13 volts. That'll give you your maximum output for amperage. Now this is really loud. Let's quiet this thing down. This alternator passes the tests.